Good evening, students. Let's wait for 2 more minutes for the other students to join. See, good evening, students. I hope you can hear me and see the screen also. Please give me your response so that we can start the class.
Yes, ma'am.
Okay. This was one of the questions which I gave you for the homework. Have you attempted this question? Can I know the reason why you have not attempted this question, Ananya?
I didn't have time. I actually had a lot of tests this week. So I don't have time to do it.
I'm not able to understand. I can hear you, but please speak a bit louder so that I can hear you what you are.
I said I had a lot of tests this week from Monday, so I
Okay.
didn't finish them.
Okay. What about you, Ritika? Okay, let me then answer the question. See, the hint for this question is you have to find a bond order of the given species. I'm using the word species because nitrogen is a molecule, rest of them are ions. They can be collectively called as species. So first thing which you were supposed to do is to write or to find the bond order of all three of them, right? For nitrogen, we did it in the last class and we came to know that it was 3, right? If you remember, then fine, else please go through the chapter or the last class itself. This was the bond order. As you can see at the top of my screen, that the bond order, how to write the bond order of nitrogen is shown here. That is sigma 1s2, sigma 1s2 anti-bonding, sigma 2s2, sigma 2s2 anti-bonding, pi 2p, put pi 2px2, then pi 2py2, pi sigma 2p z, and it goes on like that. Now, since we have 14 electrons, we know nitrogen's atomic number is 7. So N2 molecule will be having 14 electrons. So if you follow this, you will come to know, or you will find out, that the bond order of N2, N2 plus 1, N2 minus 1, and N2 2 minus. I have deliberately put the number of electrons here, right? So please pay attention to this. I'm again saying to, or rather telling you to do the same thing, because it is going to be a highly scoring and it's not difficult to do it, right? So we say sigma 1s2, sigma 2s2, and till then we will be writing for 14. So we'll be having sigma 1s2, 2, 4, 6, 8, 10, 12, and 14, right? So that means these are the electrons which we have to fill. And on this basis, we can always find the number of bonding and anti-bonding electrons, right? So with the help of that data, you can find out how many bonding and non-bonding electrons are there. And you remember the formula of finding the bond order. That was number of bonding electrons minus number of non-bonding electrons divided by 2, right? So the bond order in this case is coming to us 3. For N2 plus 1, there will be 13 electrons, because plus 1 means it has lost 1 electron, right? So it will be the bond order will be 9 minus 4, and that will be 2.5, right? Similarly, are you able to see my screen continuously?
Yes, ma'am.
Okay, but I don't know, somehow I'm seeing a lot of flicker on my screen. So give me a moment, I will just shut down the system and restart it. I think it has stabilized at it. No. See, we were talking about this. The question which I gave to you, which was that you have to find out the first target was to find out the bond order. For your help, I have added the number of electrons in the solution for you also, right? So they were N2 minus 1 will have 15 electrons and N2 minus will have 16 electrons because it has got 2 negative charge, right? As you can see, N2 plus 1 and N2 minus 1 both have bond order of 2.5. We'll have a question on it in a short while. So the first question was, which will be more stable? And as a hint, I told you that the stability depends on bond order. That means the stability of N2 plus 1 and N2 minus 1 should be equal, isn't it? Since both the species have the same bond order, the stability of N2 plus 1 and N2 minus 1 should be equal. Are you clear about my question or not?
Yes, ma'am.
So what could be the possible explanation of it? Since it is not given in your books, I have put it here. We are saying N2 plus will be more stable than N2 minus 1, despite both of them having the same bond order, right? The reason being, as I have stated it here, N2 plus has lesser number of anti-bonding electrons. That means lesser means how many it has? N2 plus 1 has got 4 electrons in anti-bonding, whereas N2 minus 1 has got 5 in anti-bonding orbital, right? And the anti-bonding orbitals, as we have discussed in the last class, are always causing instability, right? So lesser the number of anti-bonding orbitals, more will be the stability. I believe this point is clear. For every problem of MOT, molecular orbital theory, you have to write the atomic number or number of electrons. You have to find the bond order with the help of it. And then you have to decide whatever question is asked, right? Increasing order of bond length, whatever it is. So this is one type of a question. Now coming to the another question. Now, as you have seen, N2 and N2 plus, sorry, N2 plus 1 and N2 minus 1 both have same bond order, that is 2.5, right? Does that mean their bond lengths will also be same? Any idea, Shweta? Okay, let us answer this question. Let me answer it question. Again, it's an important question for your exams, whenever they are, maybe this month or in the December, wherever they may be. Both of them have the same bond order, but bond length of N2 minus 1 is longer than that of N2 plus 1. We have just discussed this thing, that N2 minus 1 will have 5 electrons in antibonding, whereas N2 plus will have 4 electrons in the antibonding orbital. As a result, what will happen? Repulsions in N2 minus 1 will be more, and hence the size will be more, right? Is it clear to you, Ananya? See, your videos are off and it is very difficult to understand whether you have understood the concept or not. So I have to keep on asking whether you have understood it or not. So please cooperate and please have a good learning. Please respond whether you are able to understand it or not.
Yes, ma'am.
Okay. Now I gave you, do you want to note it down or have you noted it down?
Yes, ma'am.
Okay. Coming to the next question. See, in the exams, it is observed that you are given the question only on nitrogen and its various species of nitrogen and oxygen and various species of oxygen, right? So similarly, for oxygen, the order is this one, right? O2, 2 plus, O2, 2, O2 plus 1, O2, O2 minus 1, O2, 2 minus. Let me tell you how we solve it. We can have a similar question on this concept in the form of, as I have stated here, write down the molecular orbital diagram of O2 plus 1. The species are same. Find out their bond order, magnetic property, and stability. Magnetic property means we have to identify whether they are paramagnetic and or diamagnetic. Let me make you recall that diamagnetic will not have any paired electron, where paramagnetics will have at least one unpaired electron, right? So here is the solution to this problem. As it was a homework, I have not written the entire answer, which we understood in the last class. Again, the first thing is that you have to find the number of electron. Oxygen has atomic number 8. O2 will have 16 electron. O2 plus 1 will have 15. Minus 1 will have 17 and minus 2 will have 18 electron, right? When you write the electronic configuration, you will come to know which is paramagnetic and which is diamagnetic. Then bond orders can be calculated on the same basis. You will get the answer as 2.52, 1.5 and 1. Bond order, bond length, everything can be based on this bond orders. This we have discussed, that bond order and bond length are reverse of each other, right? So again, to sum up the MOT, I'll say please do remember what are the orders for nitrogen and oxygen. What are the order for the smaller and the larger molecule? This is something you must have to remember. You must remember it or you must cram it. Now, there is one more thing which we must understand when we are doing the molecular orbital theory. We have not discussed about the how to draw the molecular orbital diagrams. Let us see that. I was expecting all of you to remember this, but whatever said and done, since you do not remember, I have to put all the efforts into it and just make you understand this. That what can anybody tell me what is this KK would standing for? Any idea? Do you remember the atomic orbitals were named as K, L, M, N also? KK means we are talking about the first orbit, right? We, instead of writing sigma 1s2, sigma 1s2 anti-bonding, we have written K shell of one atom and the K shell of another atom, right? So that is the significance of KK. Sometimes in your books, you will find this type of a nomenclature or this type of a structure, right? Magnetic property, bond order, you can calculate. Now, please pay attention to the diagram on the left-hand side of my screen. This is the energy level diagram. We have to understand how to draw it. Let's take it to the next page and understand how can we draw it. Again, the first prerequisite or the only prerequisite is that you must remember the electronic configuration of N2 molecule for this particular example as per MOT. First of all, what you have to do, you have to draw a straight line like this. We say this is the increasing order of energy. Now we have understood in Hund's and in this molecular or orbital, not Hund's, but rather above Hund's altogether. We have understood that 1s is at the lowest energy level. So what we will do, we will assume or we will put two nitrogen atoms at two separate places. Let's say this is one nitrogen atom, this is another nitrogen atom. Both of them will have 1s, right? So what we will do, we will draw 1s orbital for both of them, right? And both the orbitals will have 2 electrons of the opposite spin. This is, we are talking only about atomic orbitals of nitrogen. I'm writing it for only nitrogen. So the first nitrogen has 1s2. Then what nitrogen has? Nitrogen has 2s2. So I'll be drawing 2s, 2 electrons for first nitrogen, and then for the second nitrogen, 2s, right? Moving on, we will have 2p orbital of nitrogen. So 2p will be having 3, and similarly 2p orbitals of this nitrogen will also have the same thing, right? So what we have to do, we have to draw this, this, and this in this direction, this, and this in this direction. This is a pre-designed image which I cannot correct. So if you are using this one, please make a correction that the electrons are to be drawn in the opposite direction. That we have learned in hybridization and many other concepts, that the electrons have to be of the opposite spin. So what you have to do, instead of putting in the clockwise direction, you have to put it in the anti-clockwise direction. Sometimes you have seen the people and the NCERT or any other book using the complete arrows, and I, as an habit, use half arrows. The significance is that each orbital is occupied by 2 electrons. So the half arrow shows that one also. Each one is occupying half space and it is in the opposite direction. So, but just make sure either you are drawing all the half arrows or all the complete arrows, right? So, this is, I believe, is clear to all of you that how the atomic orbitals of both the electrons are representing, right? Now, what we have to do, we have to draw the molecular orbitals which are formed by the combination of these atomic orbitals. Recall the previous lecture, we said that the 2 atomic orbitals, when they combine, they form 2 new molecular orbital. One is bonding molecular orbital and one is anti-bonding molecular orbital. Bonding molecular orbital is of lower energy and anti-bonding molecular orbital is of the higher energy. So what we have to do, we will be drawing, this is, we will draw it in between 2 nitrogen. This is sigma 1s. And this we will be drawing, this is sigma 1s anti-bonding, right? We will join them like this. And this. This shows that sigma 1s anti-bonding orbital is at higher energy level as compared to any of the atomic orbitals as well as sigma 1s bonding orbital. Then what we have to do? We have total of 4 electrons, 1s2, 1s2, 2 times. So what we will do? We will put 2 electrons here, 2 here and 2 here, right? Now, similarly, now you can understand, we'll be drawing the sigma 2s in the same way. Is it clear to you, Ritika, now?
Yes, ma'am.
Any one of you, Ritika, Ananya, Ritika has said she's fine with it. Ananya and Shweta, any issues with it?
No, ma'am.
Okay. So what we have to do? We will be drawing 2s in the same way. That bonding 2s will be at the lower energy level and anti-bonding 2s will be at the higher energy level. Again, I'm emphasizing on the same point. Please draw these things very carefully. It is a 3-mark question, which are very easy to score. So this is sigma 2s anti-bonding, and this one is sigma 2s. Now coming to 2p orbitals, we get total of, there are 3 2p orbitals, so we will be getting total of 6, because each of the nitrogen will contribute 3 each, right? Now, when we talk about nitrogen, we say the energy level diagram says, first we will have a pi 2py and pi 2px at the lowest energy level. Then we will have sigma, then we will have pi, and then we will have sigma. Is it clear to all of you?
Yes, ma'am.
Okay. So we will be drawing them in the same way. So what we will do? I'm short of a space. So just bear with me and please try to understand. On the right hand side, everything is correct except for those arrows for which I have shown you the corrections. So what we have to draw, first of all, we'll be drawing pi 2px and pi 2py. They will be of equal energy, right? So at the bottom, we should be drawing between the same 2 lines as I showed you. This is pi 2px and this is pi 2py. Both of them are of same energy, so they should be equal in size at the same height and should have both of them should have a 2 electrons, right? Then we have sigma 2px. So this should be slightly lower than this. It should be lower than the atomic orbital, right? So I'll be drawing sigma 2px like sigma 2pz, sorry, like this. This is pi 2px, 2py, and pi 2px, right? Then we'll be joining them with these orbitals. Now moving on, what we have to draw pi 2px anti-bonding and pi 2py anti-bonding, right? We will connect them with a straight line, and please remember they have to be slightly higher than the atomic orbitals of nitrogen. And at the top, we will have sigma 2pz anti-bonding, right? Even though it is not filled, we have to draw it. Please remember that also. So we will be filling the electrons now. What we have to fill? We have to fill 14. So we have already filled 8, right? So this will be 9th, this will be 10th. Please remember, pairing will start when each one of them of equal energy gets same number of electrons or at least 1 electron. This will become 12, and if I put 2 electrons here, this will become 14. Is it clear?
Yes, ma'am.
Okay. Will you be able to draw for oxygen if I say right now? Okay. But in the next class, that will be the first question. Till then, make a lot of practice on this. Now, this one should be pretty easy. H2, H2 plus 1, He2. I'm giving you 2 minutes to solve it. Did you get anything, Ananya? And or how are you approaching the question?
1 minute more.
Okay. Please look at the screen. This is the NCERT which I have just opened for your understanding, that this type of a question can be asked. They don't ask for the elaborate answers, but they definitely ask for writing these two, sigma 1 is 2, sigma 2 is 2 type of a thing, then magnetic properties. So please remember that it is very important for us to know this particular configurations and energy level diagram. Again, they have drawn the energy level diagram in this form. The thing which is shown on the left hand side, this is exactly what we have done just now, right? The thing which is on the right hand side is never asked, but for the left hand side, it is obviously a very obvious question, right? So, Ritika, what do you have solved in this question? Shweta, are you able to solve this question?
I tried to solve it like the way you were writing, how many bonding pair and anti-bonding pair it has.
Okay, good. At least you're moving in the right direction. Let us see this solution without wasting any time. See, H2 plus means it should be having 2 electrons, right? Hydrogen has 1, so H2 should have 2. Now, I have given you H2 plus 1. Now, H2 plus 1 means it will have only 1 electron, right? So, the configuration will be sigma 1 is 1. Bonding electron will be 1, anti-bonding will be 0, and the bond order will be half. Similarly, for H2, it will be having 2 electrons, and this will be sigma 1s2. So bond order is 1. He2, if you recall your last or before that last we have done, He2 does not exist, right? Because it has 4 electrons and the configuration is sigma 1s2, sigma 1s2 anti-bonding. So bond order will be 2 minus 2 divided by 2. That will come out as 0, right? So bond order is 0, 1 and half in this case, right? So then we have discussed that the question is saying that explain why bond length of H2 plus 1 is longer than H2, right? It should have been the same case or the opposite case, Ritika?
No, same case.
Bond length and bond order are inversely related, right? So that means between 1 and 0.5, half is 0.5. So 0.5 should be shorter, right? But there is a reason for it, right? H2 plus is longer than H2 because H2 plus has only 1 electron present to shade, right? The reason being, remember, we have to recall that we did that in molecular orbital, the electron is under the influence of 2 nuclei. If we can draw it, we will be drawing it like this. There are 2 nuclei of hydrogen and only 1 electron, right? That's what we mean to say here. The 2 nuclei are going to repel each other, right? Is it clear? Whereas in H2, you have 2 electrons and 2 protons. So repulsion is less as in case of H2 plus. Hence, the nuclear separation is H2 is more than H2. H2 plus is more than H2, and hence we are getting a reverse order. So this is one of the important questions, and there are no exceptions, right? Or no more questions can be asked on this topic. We have covered, or at least I have tried to cover, the maximum type of a question with exceptions and with normal things, right? So do you want to note it down or is it done? Okay. Again, I say then if I allow you to write it, would you like to write it or not? One thing which you must remember, between N2 and O2, we did solve this question. When you write the configuration of nitrogen, all 14 electrons are paired. But when we move to oxygen, we have 2 electrons left before filling of the pi orbitals. So we give them 1 each. As a result, it is having unpaired electron and it is paramagnetic. This question can be done only if you, this question can be done only when you are able to write the configuration. You have done a thorough practice in configurations. So which of these does not exist? This should be pretty easy for you to do. We know O2 exists. Pretty easy to do because it's, I have just put this question. It's instead of solving it, you know, O2, F2, N2, what is left? Be2. Just check for Be2, right? That atomic number of beryllium is this. Write the atomic and molecular orbital configuration to know about it. Is it clear, Shweta? That how do I get to the answer of Be2, right? No need to calculate. O2, F2, N2, we know its stages now, right? Now let's, before moving to the topic of hydrogen bonding, Ananya, one by one, beginning with Ananya, followed by Ritika and then Shweta. I want to ask for 2 minutes that is there any issue with MOT? Or it is just as simple that you have not recollected or remembered those orders, and therefore you are not able to do the following questions. What is your say on it, Ananya?
The topic is easy. Like, I think I will be able to solve the questions if I revise it once more.
Okay, that means the concept, what I get from you, Ananya, that concept is clear. But once you revise it or reconsolidate, you will be able to solve all the questions which we have discussed. Is it the same thing, Ananya, you're saying?
Yes, ma'am.
Okay, what about your feedback, Ritika?
I need to revise this topic again.
Okay, Shweta, you?
Yes, if I revise and like solve more questions based on this, and I will like understand it
Okay,
better.
I'll for the last time, probably I'll be repeating myself. It's a very important topic from the perspective of your internal exams. So please, if you remember only those 2 threads of configuration of nitrogen and oxygen, almost all the issues will be solved. You will see only 2-3 exceptions and I have discussed all of them. Now, moving to what is hydrogen bonding, which is the last topic of this particular chapter. Now, it's very easy as compared to MOT. MOT, I understand, was very heavy as compared to the rest of the topics, right? So even after finishing the chapter, if you have any issue, you can always catch me anytime, right? So first of all, hydrogen bond is not a bond. The name itself is misleading. It is an attractive force only. That is the first thing. You must put it in your copies. If I say bond to you should mean ionic bond, covalent bond, metallic bond. That's all. And coordinate bond. 4 types of bonds are there. Although they are also force of attraction, but it is, as you can see on the definition on on the screen, that it is a weak electrostatic force of attraction between partially positively charged hydrogen atom with highly electronegative nitrogen, oxygen, and fluorine atom of same or different molecule, which is called as hydrogen bond, right? The second thing is the hydrogen bond is weaker than covalent bond. We say that ionic bond is very strong bond because it is formed between the atoms which are oppositely charged. One is positively and other is negatively. In chemistry, we understand that the opposite charges attract each other a lot. And covalent bonds are formed by sharing. So that means ionic bond is strong, covalent and coordinate bond is weak. And hydrogen bond is still weaker than covalent bond. So whenever in the longer run means when we will be discussing organic compounds or inorganic compounds, we will be saying that at times we'll be saying covalent bond is stronger. Sometimes we'll be saying covalent bond is weaker. Please remember, it is a comparative term. Covalent bond is weaker than ionic bond, but stronger than hydrogen bond. Clear? Now, we say such compounds must have hydrogen attached to nitrogen, oxygen, or fluorine. I'll give you example because this point is very important when we talk about solubility or hydrogen bond in aldehydes and ketones. This name might be looking alien to you, but we'll be taking up that in the next chapter itself. So if you have an organic compound like this has C double bond O, then it has got CH3 and CH3. And we have another compound, CH3, C double bond OH. What would you expect? Will both of them form hydrogen bond or only one of them form a hydrogen bond? I will name this compound as 1 and this compound as 2. Give it a thought for a minute. This is compound number 3. Out of these 3, the answer can be none of them will form hydrogen bond. The answer can be all 3 of them will form a bond. Maybe 2 will form, 1 will not form. So please use your jurisdiction, the definition given here. Look at compound number 1 carefully. Can you see hydrogen attached to oxygen? Ritika, can you see hydrogen attached to oxygen?
Yes, ma'am.
See, okay. Anybody differs from Ritika? I'll say I can't see oxygen attached to hydrogen. C double bond O, oxygen's valency is 2, and both the valencies are satisfied by this. So I will say I don't see hydrogen attached to hydrogen. But if I look at a compound number 3, this has oxygen and hydrogen. Oxygen has hydrogen attached to it, isn't it? Do you agree, Ananya, with this?
Yes.
Shweta, what is your opinion?
Yes,
Will the
ma'am, I
compound...
agree with you.
Okay, so that what does that mean, Shweta? The compound 3 will form hydrogen bond or all 3 will form hydrogen bond?
Compound 3 will form hydrogen bond.
Okay, correct. So that is the catch when I have written this fact. Please remember, such compounds must have hydrogen atom attached. I'm not saying oxygen atom present. I'm saying oxygen atom attached to nitrogen or oxygen or fluorine, right? So that means only this compound, compound number 3, will form hydrogen bonds. And in short, we say, I can write it as H bonds. This will form H bond, but they will not form hydrogen bond. Is it clear to all of you? Because this is a very small concept, and believe me, it will be ruled over class 12th also. All the book 2, organic chemistry, carrying 34 marks. One of the question is on hydrogen bonding and solubility, which are related to each other. So please, it's very easy. Just the key thing you have to understand, if you can find hydrogen attached to, not present. I'm repeating again. Hydrogen attached to oxygen or fluorine or nitrogen. Only then hydrogen bond will be formed, and it changes many properties. One of them is solubility, right? So hydrogen bond is a weak bond which is formed or found in the compounds which have hydrogen attached to nitrogen or oxygen or fluorine, right? Let's move on. The question is, I have given you that, to me again it is an important question. Chlorine and nitrogen, recall that electronegativity. If you look at the list of atoms which are going to form hydrogen bond, is oxygen, nitrogen, and fluorine. They are highly electronegative elements, right? If you remember when we were doing chemical bonding, periodic classification of elements, I told you that fluorine electronegativity was 4 on Pauling's scale. Then oxygen was 3.5, and nitrogen and chlorine both have electronegativity 3. The question is, in the list of elements or atoms forming hydrogen bond, I have given you only fluorine, oxygen, and nitrogen. Why chlorine does not form hydrogen bonds? That is again one of the important questions, right? For that, we have to understand that size of chlorine atom is larger than nitrogen. Again, this mystery can be solved on the basis of periodic table. If I can draw periodic table like this, oxygen, nitrogen, fluorine, and below nitrogen is, below fluorine is chlorine. So of course, the size of chlorine, as we know, that as we go down the group, the size increases. So these are the members of second period, and this is a member of third period. Size of chlorine will be larger than that of nitrogen, right? That is the reason it does not form hydrogen bond, right? If the size is smaller, we use the term charge density per unit area. It means in case of nitrogen, the size will be this much, and the electronegativity character will be spread only over a small area. In case of chlorine, it will be spread over a slightly larger area, right? Therefore, it will not form hydrogen bond. Is it clear? Is it clear, Ananya?
Yes, ma'am.
Okay. Let's see how hydrogen bonds are formed. The first example, we will be taking up 3 examples. We will be talking about HF, water, and ammonia. This is what HF looks like. In a simpler way, we can draw HF like this. This is one molecule of HF. This is another molecule of HF. There can be many molecules of HF. We understand electronegativity of fluorine is very high as compared to hydrogen. So this will acquire a partial negative, and this will acquire a partial positive charge. Similarly, this will acquire a partial positive, partial negative, partial positive, partial negative. So what will happen as a result of it? That fluorine of one atom will be attracting hydrogen of another atom. So we say or we draw it like this. This is the hydrogen bond. They are represented by dotted lines. Right? Similarly, if I talk about water molecule, in case of water molecule, water is HOH. HOH. I'll be drawing it like this. So what will happen? Oxygen is more electronegative. It will require a partial negative. It will acquire a partial positive charge. Again, partial negative, partial positive, partial negative, partial positive. Now then what they will do? They will form hydrogen bond between them. Oxygen and hydrogen, like that, right? Maybe if there are more molecules, that this oxygen, water can be drawn like this also. So this is delta positive, delta negative. What it will do? It will form hydrogen bond with this oxygen. Is it clear? Is it clear, Shweta?
Yes, ma'am.
Okay. Same way we can draw it for ammonia. Right? In case of ammonia, we'll be drawing it like this, NH3. We can draw the other ammonia molecule like this. See, when somebody asks me to draw the hybridization structure, geometry, I'll be drawing that distorted tetrahedral, right? Or a pyramidal geometry for ammonia, bent for water. But when we are discussing any other property, for that sake, I can draw that. Like for example, methane. Methane, we have to draw 109.28 wala bond angle, something like this. But for all practical purposes, when we are talking about some other property, we draw methane like this, right? So please keep in mind that fact also. Here we are representing something, we are explaining something. So we are using the best form of the resources, which will help us understanding the concept, right? So even if I don't write, it is delta negative, this is delta positive. They will form a hydrogen bond. This is delta negative, delta positive rather, nitrogen is delta negative. So they will attract to form a hydrogen bond. So we have seen 3 classical cases where hydrogen bonds are formed between the molecules in which fluorine, oxygen, or nitrogen are attached to hydrogen atoms, right? Now, can somebody explain me the meaning of the word intermolecular and intramolecular? Any idea? Just for my knowledge, I want to ask one question. The grading pattern or your schooling pattern, do you have something called as intermediate, high school? Apart from your 10th, 11th, 12th, have you heard 10th being named as high school, 11th, 12th being named as intermediate? Have you heard about these terms? Ananya, can you just give me an idea?
Yes, ma'am.
Do you have inter colleges in your state?
Mom, we don't have in the colleges, but then we have high school.
You have a high school, but you don't have an inter school or inter college, right?
No.
Okay. See, very early in the education system, at least in Uttar Pradesh, I can tell you, we use because that gives a correlation how to understand these terms, inter and intra. They used to their high school, intermediate, and degree college. High school is referred as class 10th, intermediate is referred as 12th, and degree is like BSc, MSc, so BSc rather, sorry, BSc, BA, something of that type, right? So inter means it is in between high school, which is very low grade, in terms of being educated. High school is the first pedestal or the first, what I say, first point in the ladder of learning, right? Then comes the intermediate, then comes the degree. Degree at some point of time, maybe around 20, 30 years ago, used to be something very big. Everyone was not able to reach to the college at that time. So intermediate is something in between what we call in that society at that time, very less educated and highly educated. So intermediate means in between two. Similarly, intermolecular. Now, can anybody give me the meaning of intermolecular now? I will take a clue from there and I'll say it is in between two molecules. Intramolecular means within same molecule. Right? So hydrogen bonding can be of two types or is of two types, intermolecular hydrogen bonding and intramolecular hydrogen bonding. The intermolecular hydrogen bonding, now on the basis of what we have discussed about inter and intra, inter means between two, intra means within the same. Can you classify these three examples as intermolecular or intramolecular? Ritika, what would you say it as? Intermolecular or intramolecular?
No, I'm not sure about it, ma'am. I think intermolecular.
Yeah, you are right, Ritika. Be confident. See, can you see it between two different molecules? I'll put the numbers then. This is one molecule of HF. This is another molecule of HF, right? So they are in between two molecules. That is the reason of me giving you a story that what is intermediate, right? Intermediate means in between two. This hydrogen bond is between two molecules of HF. Similarly, all of them, you can see this is one molecule of water. This is the second molecule of water. They are held together by hydrogen bond, right? So this is a intermolecular hydrogen bonding. Let's take the example of intramolecular. So this is what we have just covered. As I have told you, hydrogen bonds are represented by dotted lines. The physical state of this we will take up later once we understand, right? Then hydrogen bonds have a strong influence. I have told you they alter certain properties, especially the physical state, solubility, and all those things. Then we said that hydrogen bonds are of two types, intermolecular hydrogen bonds and intramolecular hydrogen bond. This is we have just covered, right? That how hydrogen bonds are formed between different compounds, between two molecules of the different compounds. Ammonia, water, this we have already covered. Now coming to intramolecular hydrogen bonding. I'll draw the detailed structure for you. These names should be sounding difficult for you. This one is read as, this O is read as ortho. This is orthonitrophenol. This compound is salicylic. Whatever painkillers you apply, the ointments that having iodex sort of a or a Volini gel sort of a smell. Do you know these brand names, Ananya? Volini and iodex. I'm not too sure. They may be selling in the different regions of India under different names. What I mean to say is, say your wrist has twisted or you have a twisted ankle, there is a too much of pain in your ankle or a lower foot, you apply a spray, you apply an ointment. That is the common brand names used in northern part of India, Iodex, Volini, etc. Right? They contain salicylic. So if I talk about orthonitrophenol, let's do it in a detail first. Orthonitrophenol. I think you remember or recall this compound as benzene. It has to be a perfect hexagon. Let's draw a better version. This compound is benzene, right? I said we will be having this compound is orthonitrophenol. So we have OH group here. That is, this compound is now phenol. Nitro means at ortho position, we have NO2, right? So we say this compound shows intramolecular hydrogen bonding. That is, hydrogen bond is formed within the molecule. How? Let's see. This is O and this is H. We can draw it like this. Similarly, NO2 bonding, if you remember, N double bond O, and then we will be drawing a coordinate bond. What happens in this case is that hydrogen bond is formed between, now this is delta negative, this is delta positive, right? This one is delta negative. So this forms a hydrogen bond, right? It is within the molecule, therefore it is called as intramolecular hydrogen bonding. There are only two examples in your syllabus. One is orthonitrophenol and the other one is salicylic. Now let's see how it is drawn. In this case, let's put me on a new slide. The simplified structure of this compound can be, this has got COOH. This one is a carboxylic group. You can go back to your class 10th and recall, this is a carboxylic group, right? And this is OH. This is alcoholic group. So what we do here is, we draw it like this. We'll be drawing C double bond O, O and H. And the phenol is drawn OH. This is delta negative, this is delta positive. This is delta negative, this is delta positive. So what best can be done? This oxygen can form hydrogen bond with this. Again, this is an example of intramolecular hydrogen bonding, right? Is it clear? Is the difference between intermolecular and intramolecular Hydrogen bonding clear to all of you?
Yes, ma'am.
Okay. Now, moving on, we will be studying their characteristic properties. Okay, let's take them one by one, whatever are most important. We can say they are formed due to the dipole-dipole interaction. Remember, have we discussed about the Fajans rule and have we discussed Fajans rule?
Yes, ma'am.
Okay. We have talked about dipole-dipole moment also. So dipole, you remember that was charge into bond length. So as you have seen, OH will be delta positive and delta negative. That's what we say. They are represented by a dipole-dipole interaction. Then the hydrogen bond formed with the fluorine, oxygen, and nitrogen. This is the decreasing order of their strengths, right? The strongest will be fluorine, the bond with the hydrogen bond with fluorine, followed by hydrogen bond with oxygen, followed by hydrogen bond with nitrogen. Then it's not necessary that we draw it all the time, but we must remember they are always in one plane. One plane means in the same plane. They may be like this, they may be like this. On the piece of a paper, you may think that they are not in the plane. They are, as long as you are drawing in the copy, that is one plane, right? Then they can exist in any physical state, solid, liquid, or gas, right? Then so in solids, they are strongest, liquid, they are less stronger, and gases, they are weakest. Now, there are various techniques to detect hydrogen bond because that is the one of the obvious questions that you can measure the dipole moment. If there is a resultant dipole moment, there is a hydrogen bond. Solubility behavior. We'll take about solubility means if something is soluble in water, that means it is able to form hydrogen bonds with water. You must have noticed or used vinegar. Do you know what is vinegar? How many of you love Chinese? Ritika, do you love Chinese?
Yes, ma'am.
Okay. The Chinese noodles always have vinegar. Vinegar is, we call it as, again, recalling your memories of class 10. Vinegar is, this is acetic acid. Or if I talk about the IUPAC name, it is ethanoic acid. Vinegar is what? It is acetic acid plus water. You will never see where is water and where is acetic acid. I can, just for the sake of understanding, we can draw the hydrogen bonds in acetic acid like this. This is CH3, C double bond O, OH. And then we can draw water, H, O, H. Oxygen is negative, this is positive. This is negative, this is positive. Sorry. So what will happen here? The hydrogen bonds will be formed between H plus of, let's say, acetic acid present in the vinegar and oxygen, right? So we say anything which is able to form hydrogen bonds, they will increase the solubility. Therefore, vinegar, you take a small amount of vinegar, add water to it. Even if you add the double the amount of water to it, the two layers will never separate. Of course, what we say that pungentness of it may decrease. It will become less tangy or less pungent, but they will be soluble in water. Again, you can see it is important. The compound forming the hydrogen bond must have hydrogen atom attached to oxygen, fluorine, and nitrogen, right? So that is what we mean to say. It affects the solubility behavior. If you see something and add water to it, if completely dissolves in any proportion, that means it is able to form hydrogen bonds. If it does not, you take any oil, put some water, they will never dissolve. Why? Because they don't form hydrogen bonds, right? Then elevation in boiling point, depression in freezing point. This, I can give you a day-to-day example. The details are in the class 12 chapter named as solutions, the chapter 1. So, can Shweta describe the process of making tea? How do you make tea?
You want me to tell how to make tea?
Yeah, how do you make tea?
Uh, you will take water and tea powder, boil
Okay.
it, then add milk.
Sorry to interrupt, Shweta. When will you add tea powder? At the beginning or once the water boils?
After the water boils.
Okay. So I'm just trying to write what you are saying. Water boils, then what do you add? You
You have to add
add.
tea powder, sugar.
Okay. Okay.
After that comes to a little more like boil, you have to add milk,
Okay.
and then the tea is ready.
Okay. You have to filter it before you eat. No, drink some.
Yeah.
Right. Now, my question to Ritika and Ananya is, see, and even Shweta, the same question. Most of you should be following this. But if I wish to make a tea, I want to take water, tea, sugar, milk, all together at one step, and then boil it, cool and filter and drink. Can you see any difference in these two processes? There is a science behind it. I tell you, why? Now, first of all, Ananya and Ritika, tell me, do you follow the process 1 or process 2?
One process one.
Good, Ritika. Ananya, you?
Same process 1.
Process 1. Now, I'll tell you why we do not follow the process 2. The reason being, again, just try to understand. Pure solvents can be boiled easily. Pure solvent means water. Water is a solvent. I believe you understand what is solute, solvent, and solution. Solution is formed by mixing solute and solvent. Solute is something which is present in a small quantity. Water is a pure solvent. When we are boiling it, its boiling point is less. But when we add tea, sugar, milk all together, now what it has become? It has become a solution now, right? That is the reason, and it will take up longer time, more fuel will be consumed. So in order to consume energy, in order to consume fuel, we must always prepare tea by the first method, right? So that is where the science is important in day-to-day life. We say elevation in boiling point. Technically speaking, what you are doing is you are avoiding elevation. Elevation means increase. The boiling point increases, as I have told you, that solutions have a higher boiling point as compared to the pure solvents, right? So what will happen? It will take longer time. So if you see that boiling point of water has increased, that means it has formed hydrogen bonds. It might have formed with milk or maybe some tea leaves or maybe with sugar. So if we observe elevation in boiling point or depression in freezing point, any one of you, have you tried to make ice cream using your refrigerators or the fridge? Or have you noticed anything there? I'll tell you one activity to do. If you have any type of a soft drink at your home, maybe Coke, Pepsi, or anything. Otherwise, you can make lemonade, right? Take 2 utensils of approximately same size. In one, put some pure water. In another one, put some lemonade, right? Lemonade or soft drink, whatever it is. Put it there and tell me which one freezes earlier. Anybody having first of all, do you make ice creams at home?
No, ma'am.
Do you have a cold drink at your home, Ritika?
Ma'am, we don't drink cold drinks.
Okay, what do you drink then? Tell me. Coffee?
No, ma'am, I don't drink coffee.
Somebody at your home, your mother, your father, your brother, sister, anybody?
They drink tea, ma'am.
Okay, so do one thing. Take tea, take water. What I mean to say, what I'm saying, please understand. I'm saying make a solution. Water is a pure solvent and tea is a solution or it is a mixture, right? That the filtrate of tea or coffee itself or soft drink, ice cream is what? It's a mixture. It's a solution. It's a homogeneous mixture of, say, milk, fat, flavoring agent, sugar, maybe mango pulp or a banana pulp, whatever you feel like. You will notice they will take a longer time to freeze. Try to visit an ice cream vendor. What they do, they refer it. If you just ask him and if he allows you to put the hand inside that trolley where he has kept his ice cream, you will notice it is chilling. It is very cold because they take a longer time and they are frozen only at a very, very low temperature as compared to ice. The reason being, water or ice are the pure solvents, and anything ice cream is a solution, right? So there is a depression in freezing point. Is it clear now? If you observe any of such property, that means that the hydrogen bonding has taken place. Enthalpy of mixing means enthalpy we have discussed that energy changes. Mixing means whenever in the morning you are drinking milk, coffee, tea, whatever you are drinking. If not drinking yourself, preparing it for someone else, if you mix it very quickly, you will definitely be generating lot of heat, which you may not be able to feel it. But enthalpy of mixing, we say, if you can measure, enthalpy of mixing increases. Similarly, IR spectrum. This is called as infrared spectrum. It is something like if you have seen the ECG or X-ray. X-ray is what? It's a blueprint of your bone only. But a doctor can read it and tell you whether a bone is fractured or not. Similarly, if a doctor, the heart specialist, sees the ECG of any person, he can tell you that there is a problem in the heart or not, right? Because when my daughter was 1.5 years old, the doctors detected a problem in her heart. I cannot see it. I never knew it, but they showed me the ECG and told me that, look, Shikha, these are the peaks which tell us that everything is not fine with her heart, right? So similarly, IR spectrum, infrared spectrum can be of many types. We use IR and UV most or NMR. UV means ultraviolet spectrum and NMR means nuclear magnetic spectrum. There's no need to understand these names, just for your information. The spectrum can be of many types, right? So this is what we have covered. Now, I will just wish you to know these points because I'm not too sure. Most of the points will be covered in class 12th itself, not now. That because of hydrogen bonding, the boiling point is increases. And what does this impact? Water becomes liquid and H2S is a gas. Ammonia is a gas, phosphine, ammonia is a gas and phosphine is not a gas. HF and HCl. See, I'll request all of you to go through your periodic table. Water and H2S I can teach, or you'll be enjoying that class only if you know your periodic table. At least the P block part of it, right? On the next Monday class, you must be prepared with this. Primary, secondary, tertiary means we will take up it in class 12th. But we need to have those things at one place, because at the end of class 12th, nobody, or this is one of the last chapters of class 12, the amines. Nobody remembers or nobody wants to talk about hydrogen bonding in detail. As a result, I have seen many a times we miss it in class 11th and we miss in class 12th also. So it's better to focus in class 11, and then in class 12th, we can do the revision of it, right? So now this one, how many of you know glycerine? Do you use glycerine? Do you have a chilly winter there when your body parts are dry?
No, no.
Okay. Then tell me, do you use any moisturizer or a face cream? Okay, let's go out of cosmetics. Let's talk about everyday bread. Bread or cake even. Have you noticed that sometimes the cake is very hard and sometimes it's good to eat? Any explanation? Have you noticed it or not?
Yes, ma'am.
Okay, now I'll tell you what happens and then we'll remind of the class. See, glycerol is this compound. This compound has all free ends to me are hydrogen. So the formula can be, this can be written as CH2OH, CHOH, CH2OH. Now you can understand, theoretically, it can form 6 hydrogen bonds. This will form 1, this will form 2, 3, 4, 5, 6. Glycerol glycerol and glycerine are same thing. When you happen to visit to places like Kashmir, in winters, especially when it is too cold, your skin becomes dry. I agree, you must not have experienced it, but the cake you must know. They put a small amount of glycerol into it. What happens? This glycerol, as I told you, it can form 6 hydrogen bonds theoretically. That means it will, along with the ingredients, like cake is made by, I believe that, what we call it as a fine flour, or we call it in India as maida. I'm not too sure what do you call it there. It is, to me, it is a fine flour that which we use there. Very fine flour is, wheat flour is used, and then you put sugar, you put the everything there, the cherries and whatever you want to put it, you put it there. Then you bake it for some time. So when you are baking, what happens? The moisture content decreases, but if you add a small amount of glycerol to it, what will happen? It will form hydrogen bonds. It will keep the water molecules intact. As a result, the cake will become soft, right? Of course, after some days, if you leave it in open, it will become dry. The same thing happens with the bread. If the bread is not baked with a small amount of glycerol, it will never be soft at all. Hard bread means either glycerol is in inadequate quantity or it is not at all there. So if whosoever is interested in baking, please read about glycerol as an ingredient. Chemistry, I have taught you probably, right? So you can add few drops of glycerol, and if you want to know how to bake a cake, I'll tell you that, because I'm good at baking also. So the calculated amount of glycerol is also there. Even if you are living in southern part of India, I tell you, when your skin is dry, and every cream, believe me, has a small quantity of glycerol. For the same reason, glycerol will add water molecule on the surface of your skin. It will never be dry. It will be smooth, silky, and shining, right? So with that, is this clear to you?
Yes, ma'am.
Okay. So with that, we end up the chapter. With that, we end up the class for the now. And in the last class, as I have given you this time not a written but a oral homework that you will be recalling or remembering your P block vertically, right? Oxygen, sulfur, selenium, tellurium, polonium, like that. So we will finish up this chapter and take up the other chapter now. So till then, let's have a happy learning. Have a good day.
Thank you, ma'am.
Thank you,
Welcome.
ma'am.
Welcome.